This lab is an introduction into the relationship between force of gravity and mass. And this is a simple lab. It has a simple setup. You will either have a ring stand set up to hang your weights, your masses from, or where I have it set up, you'll have an arm here attached to one of the metal poles, and you'll have a string attached to the arm and come down to our force probe. And the force probe will be hooked into the end of the LabQuest. It turns out when you use channel 1, 2, or 3, it doesn't matter which channel you use. The LabQuest can be on, you can plug this in and out, and it won't matter at all. One thing you do need to do though, and I'll have to show you, is you need to make sure your dual range force sensor is set on plus or minus 10 newtons. Later in the year we may use the 50 newtons, but unless we tell you otherwise, everything we measure will be 10 newtons or less, so you need to do that. Once you turn it on, you will always need to zero your force probe. You wait until you've got the force probe hanging, because it does make a difference whether how the force probe's hanging about. It's sensitive enough that it will tell the difference if it's going sideways or it's going straight up and down. There's two ways to zero it. You can click on, sorry about that, you can click on sensors and then go to 0, or if you just click right on the screen on the red part, this screen pops up and you can zero it there. All you have to do is click 0. And then when you do that, you'll have almost as there. It won't be perfect, but to the third decimal point, you may have in this case, a 0.003, but that's close enough for our work. Okay. Then all you're going to need to do is to hang a weight on there, and you can it'll fluctuate back and forth. But if you keep to 1 decimal point, you should be able to eyeball that. If you want to be more exact, you can hit the green play button like we've done before. You can see how that would be 7.64 you can estimate, or you can let it run, hit the stop button, then go up to analyze and statistics and find the mean if you want to be more exact to 2 decimal points. But you should be able to read 1 decimal point just off this screen. And there's our mean of 7.64. We would have probably said 7.6 anyway. To hook it up, again, I zeroed it while it was hanging. Then you will have a string around the hook, so we have room to hook different weights on. In this case, that's a 5 and a 2. That'd be an 800 gram or 0.8 kilogram weight hanging. And then you'll just have in your lab report, I expect to see this when I check it. There's not a lot of work to do. You'll have a table with masses starting in kilograms. Starting at 0.1 is 100 kilograms, so we go 0.1, 0.2 all the way down to 0.9. You'll just read the force off, then you'll enter this in. Your mass will be your X. You enter this in either the iPad or the TI. Every student only needs to enter it in one place. If all of you want to use the TIs, that's fine. I know the iPad's kind of more fun to look at, but I want everybody to enter it in. Then you will find F as a function of mass, so your F is your Y variable and your mass is the X variable. Your instructions will have a couple details. Then we'll try to see what the relationship is between force and mass, and then we'll try in terms of gravity, and then we'll try to see if we can extend that to force and mass in general. Good luck.